So we can use these rectangles to approximate the area under the curve, which means that we're using the rectangles to approximate an integral. So when I say left rectangular approximation method, what that means is we're going to take the interval and we're going to split it up evenly. And it turns out that it doesn't have to be equal sized intervals, but it's just easier to work with if we do. We could say, okay, I want to do 3 rectangles, but I'm going to divide it here and here and there. So we've got our 3 intervals here that are not evenly spaced. We could do that, but I'm going to space them evenly. So if we were going to use 3, we would split it up into thirds. And for the left rectangular approximation method, we'll call it LRAM, we're going to use the left endpoint as the height of the rectangles. So here, here, and here. So our rectangles would end up looking like this. Roughly. Okay, so that's LRAM. You can see that for an increasing function, LRAM is going to be an under approximation, right? If the function were decreasing, which means that the left endpoint is going to be higher than the right endpoint, then this would be an over approximation. All right, so we can know, we can not only get a somewhat accurate estimate by using more and more rectangles, but we can also know if it's going to be an overestimate or an underestimate by knowing if the function's increasing or decreasing. Likewise, if we want right rectangles, we'll call that the right rectangular approximation method, or RRAM. We're going to use the right endpoints. So we already saw that, but I'll just draw it on here again. We'll divide it into 2 rectangles, just to make it easier for me to draw. So this time we're going to go to the right edge of each interval and use that right edge as the height of the rectangle. Now, quick question. How could I find the height of this rectangle here? I say I'm going to use the right edge of the interval to find the height, but what would I actually do to find the height of that rectangle? Let's say this right here is f of x. Plug what in? Yeah, it would just be, this particular one would be f of b, right? That would be the height of that one. How about this one right here? We could figure out the width of each one of these by taking b minus a and dividing by 2, and then take a plus that value. And then once we do that, plug that into f. It ends up being a plus b divided by 2 if we were to simplify that. But that's something that we could do by figuring out the width of the interval and then plugging the value that we get for this into f. Okay, last one with rectangles is going to be MRAM, where we're using midpoints. This one's not really relevant. I shouldn't say irrelevant now. This one's important because if you're doing it by hand, it's an easier one to do. The thing is, we don't have to do many things by hand anymore. We have these fancy things called calculators that do a lot of work for us. One nice thing about MRAM is it's a little bit more accurate usually. Unless it's just kind of a crazy function, then it may not be. But if it's a strictly increasing function or strictly decreasing function, we know that RRAM and LRAM are going to be either an over approximation or under, and MRAM is going to be somewhere in between, usually. If it's strictly increasing or strictly decreasing, it will be somewhere in between, which means that it's probably going to be closer to the actual value. So what we're doing here is we're taking the midpoint of the interval. All right. Now, I want to go back. I kind of skipped over something here.